What I hope to do in this video is give ourselves a more intuitive sense of probabilities. So let's go back to an example that we've seen before. We're rolling a fair six-sided die. And so there's six possibilities. We could get a 1, a 2, a 3, a 4, a 5, or a 6. Now let's say we ask ourselves, what is the probability of rolling a number that is less than or equal to 2? What is this going to be? Well, there are six equally likely possibilities, and rolling less than or equal to 2, well, that means I'm either rolling a 1 or a 2. So 1, 2 of the six equally likely possibilities meet my constraints, so there is a 2/6 probability of rolling a number less than or equal to 2. Or I could just rewrite that as an equivalent fraction. I could say there's a 1/3 probability. I could go either way. Now let's ask ourselves another question. What is the probability of rolling a number greater than or equal to 3? Well, once again, there are six equally likely possibilities. And how many of them involve rolling greater than or equal to 3? Let's see, 1, 2, 3, 4. These possibilities right over here. I could roll a 3, a 4, a 5, or a 6. So 4 out of the 6 equally likely possibilities. Or I could rewrite this as an equivalent fraction as 2/3. So what's more likely? Rolling a number that's less than or equal to 2, or rolling a number that's greater than or equal to 3? Well, you can see it right over here. The probability of rolling greater than or equal to 3 is 2/3, while the probability of rolling less than or equal to 2 is only 1/3. This number is greater, so this has a greater probability. Or another way of thinking about it, rolling greater than or equal to 3 is more likely than rolling less than or equal to 2. In fact, not only is it more likely, you see that 2/3 is twice 1/3. This right over here is twice as likely. You're twice as likely to roll a number greater than or equal to 3 than you are to roll a number less than or equal to 2. And you could even see right over here, you have twice as many possibilities of the six equally likely ones, 4 versus 2, 4 versus 2 here. And so you say, okay, I get it, Sal, if the probability is a larger number, the event is more likely. It makes sense. And in this case, it's twice, the number is twice as large, so it's twice as likely. But what's the range of possible probabilities? How low can a probability get, and how high can a probability get? So let's think about the first question. So how low can a probability go? How low? So what's the lowest probability that you can imagine for anything? Well, let's give ourselves a little bit of a experiment. Let's ask ourselves the probability of rolling a 7. Well, and pause the video and try to figure it out on your own. Well, there are six equally likely possibilities, and how many of them involve rolling a 7? Well, none of them. It's impossible to roll a 7. So none of the six. So we could say this probability is 0. And if you see a probability of 0, if someone says the probability of that thing happening is 0, that means it's impossible. That means in no world can that happen if it's exactly 0. So this right here, the probability is 0. That means it is impossible. It is impossible. Now, how high can a probability get? So how high can a probability get? Well, let's think about it. Let's say probability of rolling any number from 1 to 6. Well, I have six equally likely possibilities, and any one of those six meets this constraint. I would have rolled any number from 1 to 6, including 1 and 6. So there are six equally likely possibilities, and so the probability is 1. And so if someone says the probability is 0, it's impossible. And if someone says the probability is 1, that means it's definitely going to happen. It's definitely going to happen. So the maximum probability for anything is 1. The minimum probability is 0. You don't have negative probabilities, and you don't have probabilities greater than 1. And then you might be thinking, wait, I've seen things that, they look like larger numbers than 1. And you're probably thinking of seeing this as a percentage. So 1 as a percentage, you could also write this as 100%. This right over here as a percentage is 100%, but 100% is the same thing as 1. You can't have a probability at 110%. 110% would be the same thing as 1.1. Now this is really interesting because you'd often see someone say, hey, something for sure is going to happen or something is impossible. But even a lot of the things that we think for sure are going to happen, there's some probability or some chance that they don't happen. So for example, you might hear someone say, well, what's the probability that the sun will rise tomorrow? Well, you might say it's going to happen for sure. But you got to remember, some type of weird cosmological event might occur, some kind of strange, huge planet-sized object in space might come and knock the Earth out of its rotation. Who knows what could happen? All of these have a very low likelihood, very, 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 very low likelihood. But it's hard to say it's exactly 1. If I'd said the probability that the sun will rise tomorrow, instead of saying 1, I would probably say it's 0.999, and I would throw a lot of 9s over here. I wouldn't say it's 0.9 repeating forever, and actually there's some interesting proofs that 0.9 repeating forever is actually the same thing as 1, which is a little counterintuitive. But I would say there's a very high probability, but even something that is such a high probability, it's going to be close to 1, but I won't say it's exactly 1 because there could be some kind of quasar that blasts us with gamma rays, or who knows what might happen, but it's a very, very high probability. Same thing, the probability here, probability that, my pet gopher could write the next great novel, writes a novel, and actually not just a novel, a great novel. Just a novel wouldn't be that impressive for a gopher, but writes a great novel. Well, once again, this gopher sitting there typing at a keyboard, it would seem somewhat random, but there is some probability that it actually does it. There's some chance it does it. So I would put this at a very low one. I wouldn't say it's exactly 0. If we had an infinite number of gophers doing this forever, who knows? Maybe one of them might write that great novel. In fact, if we had an infinite number doing it forever, eventually a lot of people would say at some point you would. But just one gopher trying to write a novel, what's the probability they write a great novel? Well, I would say it's pretty close to 0. I'd throw a lot of zeros. Here, and at some point you might have something like this. So once again, not absolutely impossible, but pretty close to impossible. And so big takeaways: higher probability, more likely. The lowest probability you can get to, 0. Highest probability is 1. If your probability is more, when you talk about coin flipping, if you say the probability of heads for a fair coin, and you say, well, that's 1/2, that means it's equally likely to happen or not happen. So anything that has a larger probability than 1/2, it's more likely to happen than not. Anything that has a probability less than 1/2, it's less likely to happen than not.